All right, kiddos, sorry I'm not here today, but you can watch this lesson interactively. So if you have not already, take out your new notes packet, which you should have gotten from the substitute, and open up to notes 5-1. Today we're going to talk about simplifying, multiplying, and dividing rational expressions, but before you do that, you would need to know what a rational expression is. So the word expression means that it's going to be a series of terms, but it's not going to have an equal sign. So a rational expression is an expression that contains a polynomial divided by another polynomial. Okay, so p of x, that would be a polynomial, and q of x, also another polynomial. Okay, so let me just give you an example of a rational expression. I could have x plus 5 divided by x squared minus 4. This would be a rational expression. Okay, rational meaning it contains numbers that can be written as fractions. When we're looking for the domain of a rational expression, we know that when we have fractions, we cannot divide by 0. So when we're looking for the domain or any excluded values, we want to look at what makes the denominator 0, and those would be values that are not included in our domain. Okay, so if I'm looking at this example on the right here, I have two expressions on the top. What's on the top is not going to affect the domain because the domain of any polynomial would be all real numbers. But the bottom, I know that 2x squared plus 7x plus 6 cannot equal 0. So now I have a quadratic. I need to figure out what values would make this 0 so I know not to include them in my domain. So if I factor this, I'm just going to use the grouping method. I'm looking for factors of 12 that add to 7, 3, and 4. So I break up my middle term. Group it. I can take an x out of those first two. I can take a 2 out of the second two. So it factors to x plus 2 times 2x plus 3. Cannot equal 0. So I'm just going to scroll down here. I need to figure out what values would make this 0. So x cannot equal negative 2 from the x plus 2 factor, and x cannot equal negative 3/2 from the 2x plus 3 factor. So the domain of this would be all real numbers except x can't equal negative 2 or negative 3/2. Okay. All right. So I'm just going to clear this slide. Give me 1 second. Okay, so when we're simplifying rational expressions, essentially rational expressions are going to behave in the same way as fractions because they are fractions. So what I'm going to do is divide out factors that are the same in the top and the bottom. Okay, so let's just look at a regular fraction here. If I have 20 over 24, okay, I could technically divide the top and the bottom by 2. Okay, so that would give me, I'm dividing out a factor of 2, and I'd be left with 10 over 12, and then I'd recognize that again they can be divided by 2 to knock it down to 5 over 6. So I've divided out all the common factors to get the simplest form of the fraction. Now, when I'm looking at rational expressions, I can't tell what their factors are if they're not in factored form. So step one to simplifying a rational expression is to factor the top and the bottom. So I'm going to go up to the top. That's a 4 term, so I'm going to group it. I'm going to kind of zoom in and do it above, but feel free to use the rest of the space on your paper there. So out of those first 2 terms, I'm going to take out an x squared. I'm left with x plus 3. Then I'm going to take out a negative 1. I'm left with x plus 3. So it was x squared minus 1 times x plus 3. So really, x squared minus 1 again factors another second time. So on the top, I have x plus 1 times x minus 1 times x plus 3. This is in its most factored form because I broke it down to the 2 by grouping and then did the difference of squares. Now I need to factor the bottom. I'm just going to do that off to the side over here. So I've got 3x squared plus 2x minus 1. I'm going to do this by intuition, so I know this has to be a 3x and an x. The only factors of 1 are 1 and 1. I know that the one that's being multiplied by the 3 has to be positive, and the one over here is going to be negative to give me a positive 2. So I'm just going to put that into my rational expression. So I have 3x minus 1 over x plus 1. After you'd factored it, you're going to look at the excluded values before you cancel anything. So if I look at the denominator, I know, so step 2, state the excluded values. So I know that x cannot equal negative 1 because that would make the denominator 0 or 1/3. Now if you look at this, we have some of the same factors here. So I can cancel out the x plus 1's, which will leave me with my final simplified expression, x minus 1 times x plus 3 on the top and a 3x minus 1 on the bottom. So this would be my simplified answer. This would be my domain or excluded values. Let's look over here at a second example. So again, I'm going to factor both the top and the bottom. So the top is a difference of squares, 2x plus 3, 2x minus 3. Off to the side, I'm going to do the trinomial on the bottom. So multiply those numbers, factors of negative 12 that add to negative 1. That's going to be negative 4 and positive 3. So I can break up that middle term. Out of that first term, I'm going to take out a 2x, and the second term, I'm going to take out a 3. So I have 2x plus 3 times x minus 2. Put that back on my denominator. I have 2x plus 3 and an x minus 2. State my excluded values. X can't equal 2 or negative 3/2. I'm going to cancel 2x plus 3's to leave me with my final answer, which would be 2x minus 3 over x minus 2. You can't cancel a 2-term with a 2-term unless it's in factored form. So for example, I can't simplify the 2x and the x because the 2x is technically married. It's attached to the 3. So I would not want to cancel those. So my final answer would just be 2x minus 3 over x minus 2. Okay? You can't cancel these because they're married to the other piece of their binomial. These guys are together. So now we're going to look at multiplying rational expressions. So before we look at multiplying rational expressions, let's just look at multiplying fractions, because essentially multiplying rational expressions are multiplying fractions. So if I just go up here, if I had, let's say, 3/4 times 10/12. Okay. If I wanted to multiply those, I could multiply straight across the top, straight across the bottom, and then simplify. But I could also simplify up and down as well as diagonally. So you can simplify when you're multiplying in up and down. Or sorry, I just did up and down. Let's go diagonally. So I could simplify the 3 with the 12. 3 goes into 3 once. 3 goes into 12 4 times. The 10 with the 4. 4 divided by 2 is 2. 10 divided by 2 is 5. And then multiply straight across the top, straight across the bottom, 5/8. Okay. So when we do this with rational expressions, it's going to work the same way. Just like in the last problem, before we can do this simplification, we need to be able to recognize the factors, so we need to have everything in factored form. So let's just factor each of these. This is why you have to be so good at factoring. So I'm going to factor the top. I'm looking for factors of -6 that add to -1. That one you can do the shortcut x minus 3, x plus 2. Then on the bottom I have a difference of squares, x plus 2, x minus 2. I'm going to skip the top for now because that's a little bit harder. At the bottom, it's not a difference of squares, but I always want to try a GCF. I'm going to take out the GCF of 2x. Okay. Then I'm going to go off to the side and factor the top here. So I've got factors of -4 that add to -3. So those factors are going to be -4 and +1. So I could break up that middle term, 2x squared minus 4x plus x minus 2. Factor it. So I have 2x plus 1 times x minus 2. All right, now I can cancel diagonally and up and down. So I'm going to cancel this x plus 2 with this x plus 2. I'm going to cancel this x minus 2 with the one diagonal from it, the x minus 3 from the x minus 3. And I'm left with 2x plus 1 over 2x. Now remember, the 2x and the plus 1, since it's a two-termer, they're married. You cannot cancel those two x's because that's like canceling something with two terms with something that has only one term. If we are going to state the excluded values for this problem, we want to state anything that would ever make the denominator 0. So I'm going to have quite a few because I have two denominators here. So x can't equal -2 from that first factor. X can't equal 2 from that second factor. X can't equal 0 from that 2x. And x can't equal 3. So my domain would be all real numbers, except x can't equal -2, +2, 0, or 3. Let's take a look at this second example. So same idea, I'm going to factor everything. So if I look at that first term, first step always GCF, I'm going to take out a 4x squared. I'm left with x plus 3. On the bottom, factors of -21 that add to -4. That's going to be a -7 and a +3 times. On this next one, take out the GCF, 6x. I'm left with x minus 1. On the bottom, take out the GCF again, 2x cubed. I'm left with x minus 7. Okay. Now, keeping in mind, I can cancel diagonally and up and down. So I'm going to cancel this x plus 3 with this x plus 3. Okay. And now I can look at the monomials, the single terms, and I can also reduce those. So I could reduce the 4 here and the 2 because they're both divisible. So 2 divided by 2 is 1, 4 divided by 2 is 2. And then the x squared goes away and the x to the third just becomes x to the first. If it starts getting confusing, you can just multiply straight across the top. So what do I have left on the top? I have 2 and a 6x, which I could multiply together because they're single terms. And I have x minus 1. So I really have 12x times x minus 1 on the top, and on the bottom I have x minus 1, x minus 7, and x minus 7. Even though they're the same, they're left right of each other, so we can't cancel them, so that gives us an x minus 7 squared on the bottom. Stating the excluded values, going back to the original, I'm looking at anything that can make the denominator 0. So x can't equal -3, +7, 0 from the 2x cubed, and then you'd get 7 again from the other x minus 7, but we don't need to mention that twice. So our domain, again, is all real numbers, except that x can't equal those values. Let's take a look at dividing, which if you recall from fractions, dividing is really the same as multiplying because you just have to keep the same fraction for the first one, change it to multiplication, and flip the second fraction upside down. So when we're dividing rational expressions, just like fractions, keep the first fraction the same. Change the division to multiplication. And flip the second fraction. Then we're just going to follow the rules of multiplication. So for example, if I had 3/4 divided by 27/10, okay, I would keep the 3/4 the same, change it to multiplication, change the 27/10 to 10/27. Now I can cancel diagonally and up and down. So the 3 would turn to a 1, the 27 to a 9. 10 and 4 are both divisible by 2, so I would knock those down and then multiply straight across the top, straight across the bottom. 1 times 5 is 5, and 2 times 9 is 18. So here we have an expression that's a little more complicated because it has x's and y's, but they're all monomials. Notice there's no addition or subtraction signs, so I don't need to do any factoring here because these are already as factored as possible. So I'm going to keep the first fraction the same, change it to multiplication, and flip the second fraction over. Now to keep life simple, I might want to just say, okay, first I'm going to cancel up and down and then see what I have left. So if I do that, the x squared on the top gets rid of the x on the bottom, okay, and it just changes to be the first power. The y to the fourth beats the y to the third on the top, so the y to the third is gone, and this just becomes to the first power. So now I'm left with, on the first fraction, 3x over y. I'm going to go back to this other fraction here. The 12 and the 14 can both be divided by 2. So the 14 is going to change to a 7, and the 12 is going to change to a 6. The x to the 7th has nobody to cancel with, but the y on the top gets canceled by the y on the bottom, but reduces it to y squared. So the second fraction, I now have just a 7 on the top. I have 6x to the 7th y squared on the bottom. Now I could cancel diagonally. So the 3 and the 6 would reduce. The x on the top would reduce with the x to the 7th and make it x to the 6th. So now on the top, I have 7 over y times 2 times x to the 6 times y squared. I would just want to rewrite that so I have all my y's together. So I would rewrite this as 7 over 2 x to the 6th, y to the 3rd. For my excluded values, looking back at any denominators, there's only 2 values. X can't equal 0, y can't equal 0. That would cover all 3 denominators. This was a denominator originally. 14y was also a denominator originally, and then when you flip the fraction, this 12x to the 7th, y to the 3rd also became a denominator. So really, there are 3 places that you need to look for excluded values in division problems. So you need to look at the denominator of the first fraction and then the whole second fraction, because the top becomes the bottom and the bottom becomes the top. So those are both going to be denominators at some point. Let's take a look at this second problem. So here we want to do is we want to factor it and flip after we factor. So top is a difference of squares. Then I've got a GCF. Times, I'm going to just factor the bottom here and then bring it up to the top. So that's a GCF, 5x times x minus 3. And then maybe I can do this one by intuition. I'm looking for factors of -6 that add to -5. I know they're going to be -6 and +1. This can only be a 2x and an x. And then the only factors of the 3 are 3 and 1, so I need to figure out what arrangement I want. So I want the 3 here, and that's going to be negative to make it a negative 6, and a positive 1 here. So if I FOIL that out. If you can't do this by intuition, you could always do it by grouping. Before I get into crossing things out, I'm just going to state my domain. So x can't equal, I'm looking at this denominator first, 0 and negative 2. Then I'm looking up top because those were both on the bottom at some point. So that's another 0 and a 3. And then I'm looking at the actual denominator now after we've changed it to multiplication, negative 1/2, and also a 3 again. So I have those 4 values, 0, negative 2, 3, and negative 1/2. So now I'm going to start crossing stuff out diagonally and up and down. 2x plus 1 with 2x plus 1, x minus 3 with x minus 3. And then I can look at these monomials. So look at the single terms with the single terms, the binomials with the binomials. So the 5 and the 10 are going to cancel. The x on the top is going to cancel this and make it x to the first. So what am I left with? On the top, just 2x minus 1. On the bottom, I have a 2x and an x plus 2. Again, we cannot cancel those two x's because the 2x minus 1, they're together, they're connected, they're a happy couple, happy binomial. On the bottom, we have a monomial, and that's a singleton. Can't cancel singletons with doubles because technically they have parentheses around them. So this would be our final answer for our problem with these excluded values. So remember, factor everything first. Change any division to multiplication. You can cancel up and down and diagonally just as you would with fractions.